All right. Hey, gang. Just going to go over some terminology here in the next section dealing with graphing. If we talk about, graphing lingo, if these terms are used, you know what they're talking about when they use these different terms. So, want to go over those real quickly with you, and a lot of terms actually. If you kind of scan over my page here real quick, you can kind of see there's lots of little terms, but I'm really hoping that as I go over these terms that you're going to see that they really make a lot of sense. They're not far stretches. They're like, I've never heard of those terms before. And so I just want to familiarize you with them. So I'm done bumbling. Let's get into it. Here we go. If we take a look at the first term, okay, so we're in section 1.8. And what I've done here basically for you guys is I've written out everything on my page. And you want to take notes on it as well so that you've got some sort of record of what we did today, and you can look back over things if by chance you were to be given some, when we do a review or the chapter test, or you're having to make corrections on your test or something like that, you can look back at this page and say, yeah, I remember doing this stuff. So again, section 1.8, interpreting graphs and functions. I'm going to go kind of quickly. I don't want this video to last long. So if by chance you need to pause and kind of fill out your notes, go ahead and do that. So first of all, intercepts. It says here the point or points on a graph that a graph intersects the axis. So if there's an intersection, it is called an intercept, whether it's on the x or the y-axis. I just roughly sketched two graphs here that you can see. The x-axis and the y-axis, and so the x-intercept would be this one right here, okay, where it crosses that x-axis. The y-intercept would be this one right here, okay, so it's intercepted, okay. That sounds like a football term to me, so kind of when the other team meets your ball, that is an interception. This is where the graph meets the axis, okay. Same thing over here. Again, this is the x and the y-axis. And so as a result, the x-intercept here would be that one, and the y-intercept would be something like that right there. Okay, so again, intercepts is where the x and y-axes are crossed. The next one is the y-intercept and the x-intercept. I just talked about these, where the graph crosses the y-axis, where the graph crosses the x-axis. And we'll talk more about those later on this year when we start to talk about how to graph the equation of line, and you can see that there. The line of symmetry. Now, I hope we know what symmetry means. It means to be the same on both sides. And so if we're going to draw a line of symmetry in a graph, okay, so let's think about this for a second. If I was to go ahead and draw something like this, this is my graph, okay, this is a function. Okay, the vertical line test is passed. I would say the line of symmetry would be somewhere right in here, okay? I've got the same amount on both sides. And maybe it's a little bit closer to the y-axis, but it's somewhere right in there. I'm going to change that because that doesn't look quite right. Maybe like right there, okay? So this line would be the line of symmetry right there, the same on both sides. The reason why it says here a vertical line that cuts the graph in half, the reason why it's got to be a vertical line is this. If you were to have a graph like this, okay, something like this, remember that's not a function. It doesn't pass the vertical line test. And so as a result, there would be no horizontal lines. Even though this would be a line of symmetry for this graph right here, this would not be a true function, okay? So just something to think about there. All right, so more graphing lingo. As I look down here, more graphing lingo. Gotta get my camera set straight. Functions are positive when above the x-axis, okay? So, if I were you, I would pause it right now and just go ahead and write all these terms out. Functions are negative when below the x-axis, okay? And I'll show you a picture of that here in a second. Same thing with all the rest of these. Functions are increasing when they go up. I think that makes a lot of sense. Going up, it's increasing. Functions are decreasing when they go down, okay? And so that's pretty much self-explanatory. Relative minimum. Now, I think we all know what minimum means, right? To be the smallest, okay, or the least. And then relative means in comparison to what is around it, okay? And so I wrote down here, when compared to the other surrounding points, these points are the least. And I'll show you a picture of that here in a second. Same thing with relative maximum. When compared to the other surrounding points, the points are the most, okay? So let's look, and right here on is a nice little table, and I'll see if I need to zoom in. Maybe I can come down here a little bit. Okay. This is a highly professional video. Don't be laughing. Okay. So as we look at this picture here in your textbook on page 59, what I want you to see is that it's positive, okay, if it's above the x-axis. Because if we go below the x-axis, then anything below the x-axis is considered a negative value. And so the function is positive when it's above the x-axis. Here it's positive. Even though it's decreasing right here, where my pencil is, it's going down, it's still positive in the positive range. These are both negative in the negative range. This one's easy because it's going downward. This one's going upward right here, but it's still in the negative area. So we would call that function negative throughout that part right there. I think increasing and decreasing might be the easiest. I'm going up at this point right here, so it's increasing. I'm going down right here, so I'm, hold on, decreasing. Oh, because I'm coming from left to right. Okay, sorry. I was actually going the wrong direction here. Disregard what I just said here. When we go from left to right, this would be coming downward at this point in time, so that's why it's decreasing right here, okay? Once we get to a transition point, it starts to increase, okay, reading from left to right again, and then we're going downward after that. So that's funny that I just said that, the fact that I said it was the easiest of all, and then I made a mistake on it. My bad. All right. I'm not going to worry about end behavior, so you can ignore that right there. But as far as relative extrema, we call it relative extrema, the extremes that are relative, meaning with respect to the surrounding points. As I look at this graph right here, this point, relative to all the points it's surrounded by, is a relative minimum. It's the lowest value. Likewise, this is a relative maximum point right there, okay? So just keeping that in mind, I want to take a look at one problem from your homework to make sure that you're okay with it. And I'm actually going to give you a hint or a suggestion on another problem here. So as I turn the page over, and we want to look at, I don't know if I can get this far enough away. Okay. Okay, so we're going to look at number 7. Yeah, I picked out number 7 for us to look at, okay? So there's several things that the directions say we need to look at. And I know that you can see the picture there. I'll read the directions here. It says, identify the function graphed as linear or nonlinear, okay? Now, the root word of linear is line. So if your graph looks like a line, then you have a linear graph, okay? So in number 7, is that linear or nonlinear? Well, we would consider number 7 right here. If we got an arc, it's not a line. We're going to say that's non-linear. Okay. Now, is there any symmetry? Well, I would say that there would be an axis of symmetry right in here. Okay. Right about that line right there. If I was to guess, it's about the same on both sides. So I'm going to go ahead and say we're going up by 4 each time. So this would be 8, this would be 12. I'm going to go halfway in between that. And I'm going to say that that line, that x value is 10. So the line of symmetry will always be x equals a number. Because if you graph that in Desmos, okay, and I'd encourage you to do that right now, graph any line where x equals a number. It can be positive or negative. All you're going to see is a vertical line. So I'm going to go ahead and do x is equal to 10 is my line of symmetry, okay? Now, as I look at number 6, which is one of them you have to do, is there a line of symmetry in that one? And the answer would be no, okay? If I look at number 7, after that, let's see here. Interpret the graph any symmetry, where the function is positive. Okay, now remember the function is positive when it's above the x-axis. So if I look here on the x-axis, and anywhere above, it's positive. So I'm going to say from, that's going to be a guess, -1 to, let's see here, 16, and we're going every 4, so that'd be 20. I'm going to say that that our graph is positive as we are greater than -1 and less than, let's say, 20. It's an approximation. It's not an exact science. So greater than -1 and less than 20. Now, as I write that out, here's what I'm doing over here. I actually wrote that out on my paper here. X is greater than -1 and x is less than 20. If you just want to write it out, less than -1, greater than 20, I'm okay with that for right now because we haven't went over these inequalities much. Okay, so where is our graph negative? Okay, well, our graph is negative when it's less than, when x is less than -1, and when x is greater than, let's see here, 20. Okay, the way the arrows show it, outside of those two areas, we're going to have a negative graph. Okay. It's interesting. I just started looking at this. I should probably define my X and Y values. We have an advertising expense, so how much money you spend on advertising versus the profit. And you'll notice here that if you don't spend any money, you make a little bit. But if you spend some money, okay, which would be in this case, if I'm reading this, and maybe that's how I should answer this. If I'm reading this, I'm going to say $10,000. Okay, so $10,000 would be the line of symmetry, that point. Okay, if I spend $10,000, my profit would be up here 20. So every 10, $35,000. Okay, so that's a good rate of return. But there comes a point where I just overspend, and the advertisements become too expensive, and so it looks like if I spend $20,000 on advertisements, I'm at a break even. I'm not going to make any money. Okay, so I shouldn't say break even. You just don't make any money. Zero money, zero profit. Well, I guess it would be break even if it's zero profit though. Okay, sorry, I'm babbling. Let's get back to work. Increasing. Where is it increasing? Well, if I'm going from left to right, it's increasing up to a point right here. Okay, so I'm going to say it increases. How do I write this? I'll say up to $10,000. Or maybe I'll put it this way, up to $10,000 on the X and $35,000 on the Y. Okay, that's where it's increasing, but at that point it starts to decrease, and so I would say greater than for the decreasing 10,000 on the X and 35,000 on the Y. Okay, so I know you didn't see that there. I'll put that over there on the picture. Whenever it's bigger than that point, it's decreasing, and if it's less than that point, maybe instead of using the words up to, I should use the words less than. Okay, all right, and maybe I should change this to -1,000 and 20,000. -1,000 and 20,000 to make it fit with my graph. Okay. All right, now relative extrema. Is there a minimum, maximum? There is a minimum, or I'm sorry, a maximum. The maximum is that point right there, okay? So the relative maximum I'm going to put as 10,000, 35,000, okay? And there is no relative minimum, okay? So I know I kind of stumbled around there as far as how to identify the different points, 10,000 versus just 10, or 1,000 versus 1. But yeah, we want to make sure, and back to this line of symmetry, x equals 10,000 is going to be the line of symmetry there, okay? So I hope that was clear enough where you can identify where they're increasing, where they're decreasing, where the relative min and relative max will be, okay? So because there's multiple steps here, I'm only going to have you do 2 problems like that, number 6 and 9. I want you to think through the process there for me. And then I want to go to number 26 real quick. If I show you 26, okay? Number 26 says this. Thomas graphs the function y equals 3 parentheses x minus 6 raised to the second power, okay? What is the x-intercept of the function? Well, here's the deal. We haven't learned how to graph those type of figures yet. Excuse me, but, excuse me. That was really bad. But what I'd like you to do is to graph that in Desmos so you can visibly see where the x-intercept is going to be, okay? Anyways, I hope you are doing great. Bring some questions tomorrow. We'll look things over, and we'll talk to you later. Good night.